Сегодня я хотел бы сделать доклад, такой немножко популяризаторский, немного рассказать
Hello, dear ladies and gents. I'd like to,
немного противоречивую тему.
make a
Это дебаты
presentation
о
on
защите
a
и
controversial topic
раскрытии персональных данных
of
клиентов
the protection and disclosure of client personal data
в контексте Web3. Как мы знаем, в интернете
in the Web3
проблема. Мы
context.
все
Internet
наши
has
данные
the
находились
same
в
issue. We would like our data to be kept private
когда
and
случалась какая-то
encrypted,
проблема и злонамеренное использование,
but whenever we
то
have
как бы это
any
становится
issue
препятствием. В
and
контексте
malicious usage,
это точно такая же
it
проблема, если
becomes
не хуже.
a hurdle.
Сначала я
With
расскажу,
Web3, the issue is the same. Let me say a couple of words about what Web3 is an umbrella term describing all the social and economic protocols to manage money, value, based on the existing internet infrastructure,
реестров и блокчейн.
usually based on the decentralized ledgers and blockchain.
Это не только
As you know, there's a number of working systems, not only the cryptocurrency, but also crypto assets by of countries and
Почему, в принципе,
individuals, and protecting
ну, вот если там посмотреть
personal
интернет вообще,
information of the users is important.
там популярность интернета была
If you look at the history of the internet till 1995,
каналов, появились
TLS
возможности
appeared
платить за
to
что-то.
protect channels. The payment protocols arrived. The first bookstore appeared, and in 2 years we had Amazon. And since then, the growth was exponential, and new services started to arrive. Why is it relevant to Web3? First of all, it's your right to store your personal data and financial information securely. But also in Web3, we would like to reduce the amount of the role of the intermediaries, third parties, and many applications like auctions, tenders, voting would not accept any third parties. The governments have introduced the protocols for disclosure and protection of PII, and with Web3 there are no intermediaries, and everybody would want to disclose some data about the finance and economy to avoid illegal usage. In the blockchain, the data access is needed at least to validate the transaction correctness and the integrity of the system, so this situation is aggravated by the fact that you can see what's going to happen before it happens. Like usually we have mempool for the actions that we expect to be added to the blockchain, and we have a very popular topic called front running. Of course, it exists in Web 2. In Web 3, it's more of a Wild West. You can send the request for the tender 1 second before someone else sent it and win the auction. And all the other unfair business practices, concerning salaries, other transactions. This is all very problematic with the open data. So the goal that we wanted to achieve, and I think this is the right goal for any new solution developer, in terms of the regulation and data protection, is to be on par with Web 2 world, or even better. Like if we created the bank that is better in terms of data protection than the bank and is as good as the banks in data protection, and it's great. Because currently we are, in like 95 and the TLS is still waiting. So currently, the transparency is suffering. The privacy in the blockchain networks is just achieved via a lot of third parties, and in other jurisdictions, harder to get, to find. So bad users and bad actors with bad use cases come there. So the nature of those protocols built on Web3 based on blockchain is the thing that allows you to legitimately, for the good users, to agree on some rules so that the bad users, bad actors, would not go there. So let's have a look at how it was implemented and what were the attempts and what we came to. Have some cryptographic research and information theory research in hundreds of years, and after 2008, all those new concepts for blockchain has sped up significantly, but we still have some basics from actively used on the internet, and you can build something more complex with that. Sender protection, receiver protection, information protection about this. The oldest example is 1982, when David Chappell introduced the idea of bank issuing, a paper with a nominal, signing it blindly, like signing it through an intransparent copying paper. Maybe you would not know what it is. So the bank signs it without seeing what it is because of the noise added by the user. But the user can remove that noise simple numbers rule, and this can be sent as a secret. And you can, of course, the bank would accept it, and the deal would be processed, and the bank would not know who operated it, and they cannot find the details. But the auditability of such a protocol is quite low, and that was still a very revolutionary thing. Even after the public networks appeared, there was a set of problems with hiding the recipient of the funds. Because if we use the common namespace, like with emails, everybody would see everything, and you would be able to look at the amount of emails sent to specific recipients. And then something invented by D.P. Hellman in the 70s was applied, a common secret scheme. We would use elliptic curves as a basic tool, and actually you can invent some address for the other person that he or she can use, and by using that meta address published on some public site, you can multiply this address by your own blending factor, R, and you will get a common secret that can be used to create a one-time address. So this is being used even now, and it's a good part to be used in anonymizing the recipients of funds. But another issue here is the goal of protecting the sender. Can we create an email signed by a group? And actually, there were attempts of doing this in the 17th century with a request for freedom somewhere in Belgium and Bologna. Because of that round signature, no one would know who was the first one to sign. And this is used in some voting systems nowadays, and it's very useful. Mathematically, it's quite simple. It was formalized in 2001 in an article called
Схема была такая,
How
что
do you disclose a secret?
хотят раскрыть какую-то
A
информацию.
number of generals would want to disclose some compromising information, and no one would want to be
Она на самом
the
деле
one to blame.
выглядит страшно,
So mathematically,
просто. И
it's
в
not,
2015 году
it's complex, but it works.
некоторых сетей
Well,
специально была разработана схема,
for some networks,
подписи
there was a
связываются друг с другом благодаря тому, что используется один и тот же ключ.
system designed using the same key.
Возможность построить, по сути, как бы уже финансовую модель, где купюры создаются.
The financial model was built
Подпись от лица
where you would
как бы группы купюр,
spend
связанных одним вот этим ключа.
the currency, and they would be
На
signed
самом деле, как бы суть очень
by
простая.
the specific key.
Подписи можно взять
The idea is very simple, actually.
которые тоже подходят под
Besides your own key, you can take a number of random keys that would suit this system. I know that there's 10 other notes, banknotes, for 10 rubles, for example. I can take a signature that would emulate the signatures of others and add my own signature to the list, and to ensure that the sum of those signatures would compensate, and only the real one would stay. So if you look for 3 seconds at these formulas, then the order of the signatures doesn't matter. Not the secret, but the authorship proof can be anywhere in the list, and it will work wherever you add it.
Эта схема тоже используется сейчас и для голосования.
Is used currently for voting and for finance. We created an traffic authentication scheme.
Ну, опять же, здесь есть
To
проблема.
work with financial assets. And the problem here is that the quantity and the type of the asset are not hidden. So we need to change the balance table to reflect who owns what. So we need another brick to hide the quantity using the hash function.
Самым удобным способом оказалось для этого
And the most convenient way of doing that was to replace the quantity and type of the asset in the blockchain through Petter's commitments. Petter's on commitments. We would add one thing in the elliptic curve and add a blinding factor, a random number multiplied by a number on an elliptic curve. There's a proof describing why you cannot understand the quantity, but now the commitments can be added to each other. So if you want to check the consistency of the scheme, you would be able to check that there are no random money in the system. 100 would equal 80 plus 20. So you can check the system based on the commitment levels. The commitments will be random numbers, so you cannot check them directly, but if you look here, you see that you can do the same check, see what was in the original, and you would get a point on the elliptic curve with a known generator. And because all the quantities align, all the multiplicators are destroying each other, so we get a point on the curve. And to understand this topic, you only need the algebra for, the fifth grade. So nothing complex. After getting that public key, you can form a correct signature. And because of the way that commitments were formed, the sum of the signatures is the signature of the sum of the keys. Because of that, you can create a system where the quantities and the assets are nowhere to be seen, but we know that the integrity of the system stays the same. Those schemes work well, even in the business environment.
Они, к сожалению, очень плохо соответствуют требованиям.
Unfortunately, those schemes are not compatible with the realities, business cases, and the requirements by the government. So those schemes and protocols that were built on those tools do not correlate to what we need in real life, like with, buying coffee or paying salaries, would not work here. Otherwise, we would see this in action. So what do we need here? We need the cryptography that would look like, blue tape, universal glue that would connect all the applications. And for the parallels, I think the snarks are a great example from the other presentation. Imagine you have a book that Alisa says she knows by heart. So to prove that fact, she is offered to say how many letters, like letter A, are there on the specific line in the specific page. And she doesn't know the page beforehand. So everybody would check it using some template that shows only the letters A on this specific page, like we had many of those done by some third party. So the idea here is that if we implement this protocol in the real life, and Alice would say that there were 13 of them, then probably she knows War and Peace by heart. And there's some program that would turn the pages to a specific line, and Alice, by knowing would know the arguments that give the result, which is 13. Like the secret argument would be War and Peace book. The verifying party doesn't even need to know what the book is. They just need to agree on the program to calculate the letters. It's important to ensure that this was random. And we all can go through this ceremony, like Powers of Tao, Powers of Tao, where everybody calculates the number of page and line, and then they sum it up. So in this case, Alice would be, it would be hard for her to know where her knowledge would be checked, so she would need to really know it. Because you can repeat the test and exponentially decrease her chances for success. So instead of that letter calculating program, you can, for example, check the signature or check the knowledge about the hash. Then you won't need the password in plain text anymore. You would need to just calculate the proof of the fact that I know what I need to know about the hash for this password. Then the whole financial system with money transactions from one person to another can be encapsulated and packaged. All the lines of those information can be packaged into those intransparent boxes. Say, let's call them commitments, which are the results of applying the cryptographic function. So then, instead of using some stiff protocol like Peterson commitment, as part of this program, by knowing the argument for the program, the War and Peace would be the book, would be the argument, and inside this program, which is verifiable, you would be able to prove that you know the correct signature for the owner of the banknote number 1, and after spending this banknote, I would be able to create another one with the lower balance. But there's still an issue with us announcing that every time I spend something, I need to announce that I'm spending, the banknote number 1, 2, 3, 4, 5. But we can also create a tree of all the banknotes. Not that hard, because when we build that binary tree, where every pair is hashed till the square root. So we would need about 41 stores of that, 41 levels in that tree. So in this sense, the information about 1 trillion banknotes would just translate into a tree of 32 bytes, which means that transferring balance from one state to another, can be as many of them as you want, paying the salary to 10,000 people and them paying for services, would be coded into, changing one 32 bytes string into another. And the nuance here would be that because we don't know which banknote is being spent, we would need to save the information about what was spent in some intransparent form. So we would need to hash those spent banknotes and prove that we are not spending banknotes that were already spent. Very popular implementation of this algorithm is the one called Growth 16. And its main characteristics is that any program, like triangle angles, you can simplify this knowledge to knowing a polynomial and check it in just one specific point. So to check that this square of one side of the triangle equals to the squares of the two others, you just need to see to move all the outputs to one table. So even without the data, this program can be described. You can agree on that description, and that would be the protocol. So in our example of War and Peace, this would be the turning of the pages and applying the blinders. Applying the secret argument, in this case, would be numbers 3, 4, and 5. So if you put 3, 4, and 5 in these tables, it seems hard to prove that this all works. But the only thing you need to prove is that by multiplying the numbers on the left and on the right, you are getting the same result. So on each and every stage, the multiplication works. In math, you have a very convenient thing, polynomials, and every set of the pairs of numbers can be represented by the specific function, a polynomial function. So the correct way of the function running would be the polynomials running correctly. You can multiply them, and if you get zeros in all the points of the curve, then it means that the whole program was calculated correctly. So the book that Alice was reading is not the wrong one. The hash is the correct one, whatever you want to apply this to. So we've simplified the whole problem to knowing the polynomial function. And if we know that it has zeros on the whole collection, some collection of numbers, it means that it's divisible by the polynomial that is called disappearing polynomial. And you can check the same quality. Remember the line and the page from the previous example, which would roughly equal 1 divided by the amount of the atoms in the universe. Probability of random guess. So why would we need all those difficulties? Because we can now create random software that would check how much money I'm sending, how much money did the person, the recipient, receive, how much was spent in a month. And this all can be sent to some specific program, and the Forex control, for example, can be done by myself. I can be my own intermediary. I can be my own regulator. I can calculate whether the person I'm sending money to is from some blacklist. And it's very easy to expand. The only issue is that it's slow currently. There's some progress. Actually, the iPhone has an instruction for polynomial multiplication in the iPhone, in the processor. So now the snarks would work much faster. But of course, currently it's not very fast, and the Growth 16 protocol would require those ceremonies that would kill the security of the system completely for each and every implementation of the application. So if we want to add some check to our law, we would need to expand the complexity significantly. Like in Ethereum, there was a ceremony done, about 140,000 people participated. And the issue is that our devices are not very fast at calculating those points on the curves. So this does not work fast. Growth 16 is not the only type of implementing this approach. Also, post-quantum resilience is a question. Hash questions appear, and now we are talking about the regulations. If we need to run those standard checks for the good users, how can they agree on the fact that their checks are made correctly? And how can they check that there are no malicious actors in the process? KYC processes, know your customer processes, usually would include checking some ID, some document, and its validity, its expiration date. And funny enough, you don't need to show your passport to somebody. So 140 countries would support the chips in the passports, and they would all support protected network protocol signing of the transactions, and there's a certificate of the authority. So inside the snark, you can prove that I have a passport, and it has valid expiration dates, and I'm the real person, without showing that passport to anyone. Actually, you can prove that this passport was not shown or used to any of my addresses previously. So the passport is only one type of those verifiable documents, and like World ID for Sam Altman by Sam Altman would be an example of that. And besides that, you can imagine a lot of options. Even the reply of some foreign service signed by that can be used, and that can be a source for you to prove your legitimacy. This all is described by the concept called verifiable credentials, and this has been developed fast, actually, in a broader internet community. This idea, this topic was discussed a lot. How can you prove that my passport is valid, but without showing it? You can create a tree of all the documents issued, and the document that I used to prove my identity, it was sometime issued. Moreover, you can use decentralized ID by W3C and give the regulator the rule to, invalidate some document if it lost its validity. And this is the way we can use to introduce ourselves as good people without disclosing anything about ourselves.
So I mentioned that, and the protocol may look like this, a super important thing. Any document is a collection of attributes, like, for example, your citizenship, your age, etc. It can be described as a set of a collection. This collection should be made as a tree, and a special scheme was created, which was called JSON LD, which can structurally give the random data, JSON data. For example, we may agree on what would be the looks of the foreign passport for an individual or a driver's license. And the MDL, mobile driving license standard, was established. And then you can prove that I have a passport which has a few attributes, like its expiry date, citizenship. These attributes are the trees of this corresponding document. It was signed by the regulator, and this document was released just like any other document, and it's done up to the mobile device. And in parallel with that, as far as privacy Web3 is concerned, the same people or other people developed similar protocols for the internet, and they have reached certain success. And this DID concept was added as an acting standard W3C, that's what it's called, and 18 months ago it was adopted. And I would like to thank Dan Abanay, the activist and the scientist and the people from IBM Research. The well-grounded things like signatures of BBS Plus were included there, and the Karmenia Slusyanska IBM signature was added there, which performs the similar function. For example, if you know the set of signatures belonging to my foreign passport for its number, for the sex, for the citizenship, and my fingerprint is also there. So knowing all that, I can prove that there is a subset without disclosing anything else, and make it secure. All these signatures are in the new RFC, on the Internet Task Force level. So it could become a standard in the next 2 years, starting from 2025, based upon the same primitives. In Europe, they are going to adopt the uniform European passport, which will utilize the verifiable credentials concept. there is an interesting episode saying that the consortium of telecom operators claimed that it will be most suitable for users' data protection. This experience has not been reused in Web3, although there is certain synergy here. Anyway, I explained everything about the signatures, so whatnot. Colleagues, we could achieve some synergy of what is done in the services. Roman IT does the same thanks to the retina scanners. It contains the images of retina scanners in blockchain from 8 billion people, and I can prove that I am a part of that tree, and based upon that, do something. So we have a similar solution from Polygon. We have open source solutions, high quality solutions that are actively developing. Like I said, apart from just separating the grain from the hull, we can also filter requests from the people with bad intentions, but we can use the same primitives to protect from DOS attacks. You can check the same verifiable credential not used twice, and the violators can be either banned or you can disclose their key and use it as proof of humanity, basically. Spam protection, and do it for the sake of the spam protection. For example, a lot of people would like more likes, subscriptions, and they make these phone calls, spam phone calls, so it could be used against that as well. Apart from know your customer, there's another know your transaction thing, which is a framework policy for all of the banks. So, how not to confuse this? Because it's the bad people who would like to use this. There was this article published in 2023. They would like to establish a class of essences as associated set providers. So if we would like to launch it in a good environment, new transaction, new deposit, you just not just limit the access to everyone, but we give special identificator to all of the people that proves that my money is a part of the multitude of the good money. So it's the thing which is entitled proof of innocence. It operates in wild nature, although in a limited way. And I think it's the only one working solution ever created. But it's got quite a lot of negative things and positive things. So I guess the regulators will never understand that. The challenges are, of course, the use of the cryptography. It's the speed of execution on different devices. So currently, the software and the devices, hardware, are not ready to generate such proof. So the systems of more or less self-delegation are in the inception stage. So we hope that the GPU will develop, so everything which is... we believe that we are currently at a stage when just the first CPU has been invented, but I think another 10 years will elapse and we'll create our own GPU, which has fewer instructions, but it does it much faster. From all of the things that do not work at all, and the regulators are trying to impose, is the viewing key, master key that encrypts additional content so that the regulator can always check this. But it's a bad solution.
не отличается от того, что сделано.
It's not different from what we have right now.
Оно ничего не защищает, то есть
Because it does not protect us against anything. Any
разбирательство.
violent activities could be performed and followed by investigation. And then the rotation of the keys and the risks of leakages are the same as with the centralized intermediaries. They're used in public solutions. However, it's a bad thing, which is obvious. And finally,
общее решение, generic, которое, в принципе,
the generic solution,
можно было бы сделать, и чего нет сейчас.
Thanks to blockchain, it could be introduced. We are currently presenting taxation reports, and blockchain can verify it without any hardcore cryptography. If we have the protocol, if the client knows this secret values from the recommitment, they can disclose all the private information for the regulator, and without any cryptography, by checking the hash functions. The client did not miss anything, etc. And the balance today equals the amount of the inbound transactions. So I think that's the quality that Web3 gives us as compared to the current scheme. But the user, unlike the previous thing, it does it like he's supposed to do.
Что мешает прямо сейчас это внедрить? Как я уже говорил, все это работает как бы медленно.
Everything works quite slowly. Apart from that, these protocols do not meet the structure of the intermediaries, of the operators, mobile operators, the central bank. They have not implemented anything like that. Whether they will implement it or not, it may be a question to us. But this is the process that started in some of the countries, and some people try to make another step forward. Here is another problem from the stealth address, and the client just doesn't know when the money comes in, and they will have to check everything just to make sure that they got their salary, which is a bad thing. And I think for about 40 years there have been a lot of articles regarding that, but people couldn't find the solution. What would be the conclusion? The parity between Web 2 and Web 3 in terms of user protection and control over the user is possible. In theory, it's possible to use the state-of-the-art technology and engineering solutions. They can become regulators. And they don't need regulators. We can describe almost everything, and we can program them in form of a blockchain and send them as instructions to the servers. So the specialized solutions, which are linked to the very exotic signatures, they have not worked like they didn't over the last 30 years because they are completely isolated from the variety of the real world. However, we can fix, you can do a quick fix, like I described previously. Of course, it will work slowly and will not be convenient, but anyway. And one philosophical talk. There are a lot of things between the privacy of transactions and the things that you have in the internet, like the encryption solutions in the messengers. And if we take a look at the trends with end-to-end encryption, we know that the regulators start combating that.
все становится
and try a more liberal approach.
Web3, да, блокчейн, благодаря структурированности.
So I think blockchain, thanks to the structured transactions it has, and thanks to that, we can use more
скажем так, инструментов, да,
wider spectrum of tools like passports and verified requests to the servers. We can still create a standard to make sure that everyone is happy. And in the end, I should say that this hackathon keeps on running. Sber is running it, and we are still waiting for this. We don't have much time left, but I think we can communicate through there and that hackathon, and you'll find the team. We have a standalone channel where people just talk to each other, and they talk about the Sber solutions. So I'd be happy to take your questions anyway.
Извиняюсь, сначала сказали с планшета, потом из зала. Окей, окей.
So they said, first of all, I take these written questions. The digitalization of the law, will the situation with confidentiality improve? That if protocols come instead of law, what about these ideas of protocols turning into laws? There are plenty of questions like that. I think there are some laws that should be done as protocols, and it will be much more effective, I think, because any law enforcer may have their own interests, and if the protocol uses the code, it's a completely different approach. So there'll be fewer violations. A quantum computer related question. The quantum computer can breach almost anything, and you need to do something about that. Post-quantum cryptography, will it be a good alternative? I don't know. I'm not an expert in quantum cryptography, so I don't know. What about compromising a secret? When you try to prove that you have a passport without having a passport, without having a physical passport. That's a difficult question. It's a long story, but the idea here is that in case of passports,
мы доказываем, по сути, знание подписи регулятора, да,
we prove that if we give someone this information on chip, it will be bad. Will we have the crypto ruble in Russia? How soon? I don't know. And that crypto ruble that we already have, it's not a crypto one. What about full story of transactions in the centralized environment? Yes, you can do that, but in terms of the engineering solution, it's a very difficult thing to do. But I know there have been a number of attempts to do that. There are some ML models that they try to do something. I see you have a question from the floor, right? Yes, there is a question, but we can't hear the question because this microphone is turned off. So unfortunately, we cannot hear what the question is. This microphone is off. I cannot translate this question because this microphone is not on.
У нас осталась всего минута. Давайте, может, я попробую ответить на это.
You only have just one minute. When you say about the trusted validator, it breaks this concept because we would like to have the open system. As soon as you add trusted participants with shared rights, the problem of censorship arises. What's your next question?
Хорошо, все, спасибо.
All right, this is it. Thank you very much. Okay, we did it just in time.
Я прочитал все.
Well, I've read all the questions here.
Ну да, попробуйте так.
That's right. That's right.
Спасибо.
Мало секунд.
Существуют ли реальные
Yes, thank you.
удобные вещи в каких-то там
Do-
зарубежных решениях, которые можно...
Do you think that there are some solutions that you can already use and touch the open source libraries that you can utilize
Шнарк и так
Вот
далее.
полны.
with ZK Snark technology?
То есть там есть
Yes, the presentations will be available. There is a slide
полигон,
enlisting
Зупас это
everything.
в принципе
ZooPass, for example,
кошелек.
it's the wallet for verifiable credentials,
И в принципе все, что делает группа,
a very good one, and everything which is privacy scaling exploration company is doing has got a lot of solutions. You can take all of them.
репозиторий, который называется
At GitHub, there is a awesome repository, awesome something, awesome ZK. That's what it's called.
сотен проектов.
There is a
Ну, в любом случае,
a few hundreds of nice solutions.
каналом, если у вас
Please use our QR code. If you have remaining questions, follow-up questions,
как бы
please contact us.
мы сами активно экспериментируем со
We actively experiment with all that.
какие-то продукты в
So maybe we'll
privacy,
have some privacy-related questions.
Ну, то есть, кроме...
So please stay tuned.
есть...
So apart from Zcash, you also have the embedded ZK Snark. Well, Polygon is the company name, and they have Polygon ID. That's the name of the product that runs a protocol of the zero knowledge protocol, and they use products that use ZK for other products, ZK VM, etc.
Это компании. Зайдите на сайт, там
These are the companies. Check them on their website.
интересно, ну вот говорю, спрашивайте, как более конкретно
And
ответим.
please send us more direct questions to the Telegram channel. We'll be happy to take them.
Время закончилось, и выберите лучший вопрос.
Your time is up. Please select the best question.
Ага. Окей, да. Так, секунду, у нас супер быстро. Ну, да, снарки можно использовать еще, то есть как бы
You can use
война и мир, да.
that on Snark, that War and Peace secret.
В том, что можно не читать как бы
And
всё.
the Snark advantage is that you can just check it in one place, and this is it.
Здесь это как бы
But in our particular case,
не совсем помогает, то есть как бы вот единственное,
it does not help much.
это сейчас
The only thing where it could be embedded is the so-called roll-up. When we roll up lots of changes into
не знаю, то вот
the rug shape and into rug, like pay 10,000 salaries
одну
and
единственную транзакцию
wrap them in one single transaction, and you prove that it's a correct one. Like, for example, the payment of the salary to all of the Sber employees is just one hash.
как бы
But unfortunately,
то есть
that
скейлинг, то есть масштабирование
roll-up scaling
как бы не улучшение качества с точки зрения
does not enhance the quality in terms of confidentiality and data of the user, protection of the data of the user.
Мне нужно выбрать вот из
Unfortunately, I'm out of time. I need to select the best question out of 3.
Вот.
Young man, you have already received this gift, and that was the young man who spoke about trusted validators. I think that's the one. Please go there and get your piece of merchandise. Thank you very much. I'll see you next time. Thank you.